the contents of this file. You will also Practice 5 Overview. This practice covers exploring a trace file to understand the optimizer's decisions. We're moving to the activity guide so we can walk through the steps of the practice. So this is the header page for the practice. Moving down to our overview, practice for lesson 5 overview. Practice overview. In this practice, you will create an Invent 153 trace file and then review the sections to recognize the contents of this file. You will also open and analyze an SQL trace file by using SQL Developer. It is an optional practice. Note, this practice is only for demonstration purposes. Do not use it on your production system unless explicitly asked to by Oracle support. We're going to move to the we're going to move down in the activity guide so we continue working on the practice. So practice 5, understanding the optimizer's decisions. Okay, overview. In this practice, you analyze the optimizer decisions related to which execution plan to use. All the scripts needed for this practice can be found in your $home/labs/solutions/trace event directory. Tasks. Number 1. Execute the te-setups.shush script file. This script file executes the following queries and generates a trace file that contains all the optimizer decisions. As we see from the query, it's doing a join of multiple tables from the sales history schema. They're doing them as a group of equal joins, okay, with some additional filters on the data. At the end, we're doing a group by operation, so we're grouping by the channel class, the customer city, the calendar quarter description. And then we also include by that grouping a summary operator to summarize the amount sold. So we're going to create a terminal session. In the terminal session, because they're kind of small, we're going to make them a little larger so it makes it easier to look at while we're working on the practices. So I zoom in a couple times, usually make it nice and big. And to exercise the practices, we've got to set up the Aura environment for our database. We type in Aura, type in /space Aura env. It will prompt us for the SID, and the databases we are using, their system ID is sys2. So that will set up the environment variables and also update our path to include our home directory. Then we want to move to the directory that contains the script files. I do that as cut and paste, just saves us a little time. And now we're going to execute this script file. That will set up the collection of the trace file with our query in it. Okay, it doesn't take too long to produce, and at the bottom we give you the names of the files. Okay, so the task 2 is, with the help of your instructor, examine the generated trace files. Okay, and interpret the important parts of them. The 153 trace file output is broken down to a number of sections that broadly reflects the stages that the optimizer go through in evaluating a plan. These stages are follows. It does the query processing, parameters used by the optimizer, okay, the base statistical information, base table access cost, join orders, and join method computation, and recosting for special features such as query transforms. Please note the output can be different based on your practice environment. So once we were in the directory, it produced the 2 trace files. The first one is called My Optimizer TRC, and they show you in the book an example of having a look at that. Let's go in and have a look at ours. There are a couple of ways of looking at it. One way is to cat it the way they did. Another way is to use gedit on it. and have a look at it. And it sometimes makes it a little easier because you can search for different things within it. And what we're going to do is just take a selective walk through this. I spend a little time looking at the beginning, and then we'll look around at different sections of the trace file just to give you a little idea of what they actually look like. So let's take a look for our trace file in here. We have a group of script files, and one of them is myoptimizer.trace, as they noted. I'm going to do it with gedit. You can certainly use cat on it if you want. I just find it a little easier with this. It is a fairly big file, so we'll use gedit. It will take a moment or two to load it up, and I just make it full screen because it makes it a little easier to go through it. So at the beginning, we document the trace file names, then we document what version of the Oracle database this was produced for. Note the major options that were available on the database. Show you the Oracle Home Next, that the database is running out of what platform. Ours is running on Linux. The node name that was it was run on. We have an interesting node pattern we use with the education environment. The version of the operating system, the version of the release of the operating system, the machine style. These were on Intel x86s, 64-bit. And the name of the instance. So I had set the SID for this earlier on before we run the script files. Which process number that actually created it, and what the PID was at the operating system. Okay. Then we do a little documentation. It was a client session we were running. It gives you the session and the serial number for the session, the client ID, which is a timestamp in this case, the service name that it was running under. So we were running under the sysusers, and the module was SQL Plus. Okay, that we're actually using to run the script file to generate the file. Then it says this is the query block name, and this is the parse signature. We're certainly not going to look at all of the features. And then we start having a look at the way the environment was set up. So automatic degree of parallelism was disabled as a parameter. Okay, it looks at different optimization. One is predicate move around, and we give you the short forms that we're using in them. And this is the current SQL statement, which is the SQL we were having a look at. And because it's a fairly complex statement, it will look at a number of operations. As it's describing the operations, it uses this set of short forms, so it documents all the short forms that it actually uses. An SM for sort, merge, a HA for a hash join, etc. I was just reading a couple at the bottom in that. So it will go in and show you, it will also show you if you're doing parallel queries, the distribution methods that it can use. And it goes through the parameters used by the optimizer. So it dumps a number of parameters, and it does include hidden parameters in here that are generally not set, but if we have to send this to support, they need to know, to work with a problem with support, they need to know exactly the way the environment is set up, whether the hidden parameters are set as the default or not. So then they understand which environment. And it goes on for quite a piece, so I'm just scrolling through it for the different parameters. As you note, as I mentioned, a large number of them are underscore. They actually have a section that documents which patches are enabled and disabled on this particular version of Oracle. And this is 12c release 1 of the database. So as I mentioned, some of these are relatively large sections. It's a little faster to just scroll through them sometimes. I'm trying to pick the optimal way of going through, and it doesn't look like there is one. because I went down faster. Then we should get to the end of the optimizer parameters. It checks to see if there were any hints used. It checks to see if column usage monitoring was turned on. And then it starts considering transformations. One of the things we talked about is it will take a particular SQL statement and try a number of query transforms. And it will consider them, and then it will document whether or not it was able to do a particular. And if you're not sure of the forms, quite often they put them up here, common expression, sub-limitation. Sometimes we have to go back and look at the version, the summary they had at the beginning. Okay, and then what they will do is they'll tell you whether or not they considered it. This one was bypassed. The order by elimination, no order to eliminate. Okay, so it goes through and looks at a group of transforms. One of it considers as a join elimination, and it will document in great detail whether or not it was able to do anything by looking at the parse blocks and describing the details about them. Okay, eventually we will come where it's actually starting to look at things like the join order. But the first thing before it does it, it looks at all the possible transforms that can be done. Large number of them that can be done. Okay, so it looks at them, and many of them in typical cases are rejected. There's probably a very small subset that actually tries and costs out, mainly because they don't provide the real information. They don't meet the requirements to do. Then it gets into the system statistics. Do we have workload statistics? If not, we're using default values. So in this case, the default value for an IO seek time was 10 milliseconds. We have a default value for the CPU speed I/O. What that really indicates, if we're using the default values, is that we didn't collect system statistics on this particular database. We should collect it during a typical workload, and then we would have actually measurements for the I/O speed, for the CPU speed, for the I/O seek time, and the size we should do for multi-read count for the database at default state, since no value was specified for it. Then it goes through the different tables and documents what are the statistics that we currently have on each of the tables. So it's going through the channel table, going through and document there are a number of rows we have, the number of blocks they occupy, the average row length, the chain count, the column number, the average length, the number of distinct values, whether it has nulls, etc. It goes through each table and documents, and it also documents the indexes that are available and some statistics about the indexes. Okay, then it will go through and analyze the access paths for the tables, and it will go through looking at single table access path, and it has some indexes. It can always do a full table scan, and it looks at them and looks for what it perceives as the lowest cost access path to access the data to get what we need. So it's going through each of the tables and considering what are the available access paths that it can actually use based on the indexes and the fact that a full table scan. And then it starts, once it decides on the access paths, then it starts looking at the statistics and looks at some permutation, and some of them are rejected. So it's now looking at joining the times table, okay, and it looks at different join methods. The first one is a nested loop join. It calculates a cost for each of the methods to consider them overall and which table it's joining it with. And it considers a full scan on an index as a possible access path. And using the access path and the join method, it will come up with the best nested loop cost. Okay, so it will now join the customer table and it will look at possible join methods to it. And it puts in justification for everything. And it will go in and look at different join orders, different join methods, and come up with it believes is the lowest cost execution plan. And it goes on for a fair bit of information. So we can go through that. So it's joining different tables. Okay, and it will go through and look at different join orders. And eventually it will come up with a total join method that is the lowest cost. So a lot of this is lots of details around the optimizer is making decisions and that. At the very end, and we'll scroll down to the bottom and back up, we have the end of the dump, but if we back up, it will show you the summary of the bug fixes that were in place. They were at the top also. So I just want to scroll back past that. But somewhere near in all the parameter values, a little further up, and it will come up with the final cost for the query block. Decided on the best join order to come up with the lowest cost to do the query overall. Okay, gives you information about that. And what I'm looking for is eventually we should have an execution plan in here. So this is the outline to force it. So it gives you an overview of the outline, and above it, which was what I was looking for, it gives you the execution plan. So this is the statement that they optimized for us. And this is the execution plan that it eventually came out as the lowest cost execution plan. So in here we've documented all the decisions, and it will document why it looked at different costs for different things. A lot of transforms it won't be able to do. It does the transforms first, sees which ones are viable based on our statement and any preconditions that have to be made to ensure they give us the same execution plan, and then costs out all the possible transforms, all the possible access path, join orders, join methods, to come up with the final execution. So as we see from the volume of data, it makes a lot of different decisions. And this is one place we can get an execution plan. We saw many when we were looking at the chapter to collect them. So let's move back to the practice guide. So we had a look at this, and the rest of the practice guide is a dump of theirs. They did the same thing. They selectively looked through it. They certainly didn't look through the whole thing as they went through it. But we had a look at a good part of it. I'm just going to scroll down and see what else is in here. We've already seen most of this looking at theirs. It gives you another alternative way of looking at it, is just looking at their sample in the book. And this is fairly large trace file, and it goes on for a fair bit. So there we got to the end of it. Okay, and at the end they clean it up. Just before we do that, we could actually look at this. Okay, if we went to this directory and pulled it up in SQL Developer, so they suggest it as an alternate way of doing it. But interesting enough, they didn't actually do it in the practice. So we can go to SQL Developer. What we want to do is reset where we're using to pull the script files from, and then we can just open it in the work area if we do that. So we go to the that is the tools, to my preferences. Okay, and this is where we found them. We want to put it in the path for this one. Let's see if it's still in. Oh, that was the file name. I'll just go grab it from the directory. It will make it a little easier. I'm in the directory already. Before I can do that, I guess we better exit out of that. Do pwd, it will just get me the directory path. It will save me going and exploring for it. We've already seen we can actually go and explore for it, so I want to copy that into the paste buffer, paste it in here, use that as my directory and set it. Okay, go back to here, my computer, and refresh it. So we now have the trace directory, open that, and we have the trace files, and we can go in and open that. And when you do that, it will load it into here. This is a very large file, so it may actually not like it, having a look at it, okay, when you load it. So I guess they didn't like it. That could explain why they didn't load it. It says it's such a large file, it didn't actually want to open it. So I'll try it again just to see if it will open it, but I don't believe it will. Okay, with it. So we'll leave them to assume that it can actually do it. Now, to complete this practice, in this trace directory, we should run the cleanup so we're ready for the next practice. Select that, copy it. I do it a couple of different ways. Sometimes I just do it as a Control-C. Execute the cleanup file. Doesn't take much, just cleans up things for us on the database. And then we're done with this practice. This is the end of this practice.